So you look at the research and you see that there's like somewhere between 5 to 20% of all code out there is duplicated to some extent. Change coupling in simplest forms is based on finding patterns in the commits. You have the teams separated based on business capabilities, right? And that those business capabilities are reflected in the architecture. Using behavioral code analysis, you can show which team works where in the source code.
This episode was made possible thanks to Gotopia.tech.
Hello, welcome to a new episode of the GOTO Book Club. I'm Sven Johann. I'm a senior consultant at INNOQ. I spend my time on improving software systems. And today I have my second conversation with Adam Tornhill on his book, Software Design X-Rays. Hi, Adam.
Hi, and thanks for having me here again.
So maybe for those who didn't listen the first time, please introduce yourself. And also for all those people, there is a first episode, and we recommend to check it out.
Of course. So I'm Adam Tornhill. I'm the founder of a company called CodeScene, where I tackle the challenge of technical debt. And my background is maybe a little bit different because I actually have two backgrounds. One in engineering. I've been a software developer for a long time, but also in psychology, which is one of my big interests. And what I try to do with Software Design X-Rays and what I work on these days is to take my psychological background and put it on top of my technical experience. So that's what I do. I'm the author of Software Design X-Rays and a bunch of other books.
All right, thank you. So in the first episode, we talked about behavioral code analysis, hotspots, X-rays, and now in the second episode, we want to start with change coupling and then move on what change coupling actually means, not on the code level, but also on the team level. So yeah, what is actually change coupling?
Change coupling is a very interesting software analysis technique. It's interesting because it's something you cannot do just based on the source code. So if we talk about coupling in general, as a developer, we typically refer to coupling as some kind of dependency, right? You have some piece of code over here, it uses some piece of code over here, they depend upon each other. Change coupling is different because it's more about logical dependencies. So in a behavioral code analysis, you measure how the organization interacts with the code they're building. So in change coupling, we pick up patterns in, it could be anything from the Git log to more advanced architectural analysis, where we pick up patterns in Jira data and stuff like that, and figure out that each time I need to modify a piece over here, I have a predicted modification in the module over here. So there is some kind of logical dependency between them. And using change coupling, we can get a lot of interesting feedback on how well our architecture supports the way we work with it. So that's the short description.
Yeah, I mean, we all know the situation where we change, let's say, a piece of code, and then, okay, now we have to change 5 completely different unit tests because of some copy-paste coding. How does a change coupling relate to clone detection?
Basically, the original challenge I had was that this was way before CodeScene, way before I wrote the book. I was working as a software consultant, right? And I was working with a team that were very heavy on test automation. And the problem they had was that they got a lot of flaky tests, right? So this was automation at the system level, at the application level. And the problem was, of course, that as a developer, you kind of you pushed some changes, you updated some tests, and then you had 3 other tests failing because they kind of also depended upon some logic. Now, using change coupling, what we could do was we could first of all visualize the changes, right? So we can figure out that you make this tweak in the application code, and now we have to modify this whole cluster of files, right? So that could kind of highlight the problem. But to make it actionable, we wanted to drill deeper and figure out, is the reason that we have this change coupling, is it due to drive violations of the don't repeat yourself principle? And adding copy-paste metrics on the top of this proved to be really useful. And to me, change coupling is an excellent way of benefiting from clone detection tools and copy-paste detection tools. Because the main problem with copy-paste is that there's simply so much of it, right? So you look at the research and you see that there's like somewhere between 5 to 20% of all code out there is duplicated to some extent. And not all of that application is bad per se. So using change coupling, it kind of gives us a window into those massive amounts of duplicated code, and we can kind of figure out that, okay, these are the software clones that are actually expensive to maintain, right? Because we have these predictive modifications.
I mean, you had it in your book. I mean, a clone is not an exact clone, right? So there is usually you copy something and then you paste it and then you change this tiny little bit. But of course, if one thing changes, you have to change all the rest. Clone detection tools also find those, like half-baked copy-paste, edit pieces of code, right?
Yeah, that's right. So I think that the clone detection in software it's a pretty old technique, right? It's something that's been in industrial use for almost 3 decades. But again, I think that simply the sheer amount of duplicated code makes it very hard to act upon it. Because to me, I think one of the main problems with copy-paste is that we as developers, myself included, we are kind of conditioned to despise copy-paste. We have learned over and over again that it's a bad thing to do, right? The problem is that it's simply not true as a general statement. Because let's say that you have a piece of code here, right? You copy-paste it, and now these 2 copies, they evolve in completely different direction. One could very well argue that copy-paste was a good starting point, right? Or maybe you duplicate some code and you never need to touch it again. It might not be ideal, but is it really a big problem, right? So the problem starts when we actually have to make those, when it copy-paste, when it kind of drives our behavior in a negative direction, right? So we have to make those predictive modifications. It's easy to miss to update one of those clones, right? And that's why I think this combination of change coupling and clone detection really, really adds value in our daily work.
Yeah, I agree that it's not always bad. I tend to, do a first-time copy-paste edit, but when I do it the second time, then, it's time to say, okay, now I need an abstraction, because, introducing an abstraction to, for a one-time thing, Dan North, he once said, try is the enemy of the decoupled. That's something I'm wrangling with, and but in terms of microservices, for example, or it doesn't even have to do microservices, just different, completely independent modules. When you see that, whenever I change something far over here, I have to change something far over there, even in a totally different repository. Then things become a bit problematic. And I wonder, how do I find out if I have a problem? Because, maybe I only have like this one-time thing, as you said, or, it's a real problem. How can I find that out?
Yeah, that's a very interesting question, because I think the whole... the incredible hype behind microservices over the past 5 to 6 years kind of flipped the whole architecture and design thing around a little bit, because there are definitely scenarios where you want to violate the drive principle, because loose coupling is simply more important, right? It's a more important capability than minimizing the amount of duplication. At the same time, what you want to avoid is to have exactly the same behavior in 2 different places, if that's a behavior that's being frequently modified. Because if you have that, it could very well indicate that maybe you miss a microservice to take on that shared responsibility. Maybe it's a separate business capability, right? So what I do, there are 2 aspects to it. One is getting the data. How do we figure out change coupling across Git repositories? The second challenge is how do I act upon it? And I wrote about this in the book. So change coupling in simplest forms is based on finding patterns in the commits, files that change together over and over again as part of the same commit set. And that clearly doesn't work across repositories. So what we do there is that you simply look at the ticket system instead. Things like Jira tickets, Azure DevOps tickets, whatever, right? And see that if the commits reference the same ticket, then we know that they're kind of depending upon each other. And if it's happened often enough, then that's a very strong signal. So that way you can kind of, even across Git repositories, you can detect change coupling down to the function level, right? So this is something that's very powerful, and you can of course add clone detection on top of that as well, and then see, is this a drive violation that's desirable, or is it an actual problem that we lack some level of encapsulation or abstraction? And what I would say is that to me, it's a hard engineering problem, right? But the more challenging aspect is to make that decision, right? Do we live with this or do we ignore it? And what I tend to recommend is I use a general heuristic that I call the heuristic of surprise. So I simply visualize the change coupling, and then I take everything I know about the architecture and the problem domain. And any surprising coupling that I find is usually bad, because, surprise is simply one of the most expensive things you can ever have in a software architecture.
Yeah, rarely people are positively surprised.
Yeah.
It's always don't make your manager being surprised, because usually it's negative. But you wanna show the coupling. So how do you show the coupling? Is it? I mean, I remember from when I looked at CodeScene, and also when I remember the book, it's like I show two files, right? And then there is like the amount of coupling of those files and how often they change together, so to speak. So what's the thinking about this approach? Showing the files and the amount of coupling.
Yeah, so the interesting thing with change coupling and a lot of those other behavioral code analysis techniques that we talked about in the previous episode, like hotspots and that kind of stuff, is that they scale at different levels. So you can use change coupling at the function level, right? You can use it at the file level, and you can use it at an architectural level. And that's where I usually start when I pick up a system. I look at the different architectural elements, and they could be either different layers, they can be different components, or they can be microservices. And I'll simply figure out the change coupling between, let's say, the different services, right? So I typically visualize it. You have all your services like a wheel, and then you see the connections between those edges. And that's usually my starting point. And in my experience, because I've been fortunate to work with so many organizations across the globe at all kinds of scale, and I see several organizations are doing really, really good job with it, but occasionally there is a surprise. And the surprise is very often that even though you put all these efforts into defining proper service boundaries, right? We know about bounded context, domain-driven design and all that stuff, right? But the thing is that it's incredibly hard in practice, because we basically have to be domain experts to do that, right? So the surprise tends to be that, hey, we're actually starting to build a distributed monolith, right? It's very easy to highlight that with change coupling, that when you change this service, right, you have a dependency to 5 other services, and then you look at the details, what kind of functions are coupled, and you often see that you implement a new capability here, a new business capability, and to pull that off, you need to query 2 different services and update the state in a third one, right? So that's the typical warning sign that I tend to find.
I can have from time to time, let's say, this coupling. As we said, maybe we have 2 code clones in 2 different services. And then, we change it once, and that's fine. It just happened once, and that's probably not a problem. If we change it a second time, a third time, a 10th time, 100% of the time, we change those files together in different services. Is there any, let's say, recommendation when I should start worrying about those temporal dependencies?
So I found it very hard to give general recommendations in this area, because with hotspots it's usually quite easy, right? If you work on a part of the code a lot, and that part of the code has a high degree of technical depth, then it's very easy to say that, okay, we need to fix this, right? But with change coupling, it's so much harder, because it kind of depends on the life cycle of the code base, right? If it's something you just got started on, there's probably going to be a lot of experimentation and learning going on. So I do expect a higher degree of change coupling and more complex change coupling, right? But I would say that anything beyond, let's say, in a more stable system, right, once the basic architecture is set, I would be worried about any change coupling that's over 20%. That would worry me.
Okay.
The other heuristics I use is basically that change coupling gets more expensive with distance. And what I mean with distance is, first of all, architectural distance. Like, are these two completely unrelated parts in theory, but in practice tied together, then that might very well be one of those surprises. The other one is dependencies that cross team boundaries, right? Because that very quickly becomes expensive because the teams end up in all these coordination meetings, and they might have conflicting changes in their API and stuff like that.
Yeah, I can sing a song about those kind of problems. I think if you have different repositories and one team is responsible for that, okay, it's not nice. But it's still, let's say, it's manageable, and it's also, I would say, it's also easy to fix because it's one team. Just a couple of people own the different repositories and can think about reducing or getting rid of that coupling. But across teams, that's going to be tricky. So what are some interesting examples from your experience on that problem?
Oh, I have so many. I'm not even sure where I should start. So I think one of the most common issues I've seen, and this used to be more common maybe a few years back, like 2-3 years ago, was that several organizations that I worked with, they kind of asked me, like, how should we organize our development teams, right? So we started out with component-based teams, right? Then we noticed that we had very, very long lead times, right, for new features, because you had to do these handovers all the time between change couple components. So we changed to a feature team, and now we kind of noticed that our whole quality aspect just went south, right? Because suddenly we find that we have 10 different teams all working in the same parts of the code. So to me, it's a much harder answer because the organizational aspect always goes hand in hand with the software architecture, right? So you really need to balance these two. And if you want to have component teams, then I think a much better approach is what the team topologies people recommend, right? With stream-aligned teams. That's the only way I've found that actually scales, that you have the teams separated based on business capabilities, right? And that those business capabilities are reflected in the architecture. I really haven't seen anything else that works at scale.
Yeah, I was about to say, in the team topologies book, they have this quote from, I believe, Ruth Malan. If there is the software architecture, but there is also the communication architecture, and basically on Conway's law. And if you don't care about, if you as an architect don't care about team setup and communication structure between teams, basically you give the architecture tasks to someone who cares, like a non-technical manager, right? And then you end up in those problems you described. Is there a way how to use those insights on a change coupling on a, let's say, based on different teams working on the same code base to refactor teams towards those stream-aligned teams?
Yes, there are. And I like to think this is one of the most important contributions by behavioral code analysis and software design X-rays, and what we do with CodeScene as well, of course. It's that it brings visibility to the people side of code. And to me, I always talk about this like the grand tragedy of software design, that the organization that builds the code is invisible in the code itself, right? So using behavioral code analysis, you can actually visualize that. So you can show which team works where in the source code, right? And you can overlay that with change coupling information so that you can easily show those bottlenecks, right? That when we modify this service here, that team have to coordinate with 4 other teams, right? You can visualize that. And from there, it's mostly about domain expertise to figure out, okay, quite often it's not enough to just shift the teams around. Quite often you have to do some more fundamental change, and maybe those 2 different services or component, maybe they are actually the same component, right? So you need to merge them together. And occasionally you find that the organization simply lacks a team to take on a new responsibility.
It's kind of, let's say, the same pattern maybe we discussed the last time. So the last time, the hotspots actually create a not to-do list. You have so many problems, but with the hotspots, you get a focus on the problem. And here we would have the same. If you need to think about your team setup or your team topologies, to use the word, basically, I can look at those parts where many teams own a lot of the same code, and also where are teams actually quite distinct from each other in the code base. And I can use that one, like the problematic part, to look at where do we need to create better boundaries, team boundaries.
Yeah, and I think that's important, because the moment you're able to visualize that, then you can start to have a meaningful conversation between engineering and the business, right? Because in my experience, even with organizations that have a fairly high degree of team autonomy, right, a team can usually not decide that. They can decide what they want to do. They can decide what they want to do differently, but they cannot decide for the whole organization, right? We need some kind of buy-in. And being able to show that data really, really helps in my experience.
If you just say you have a problem or you have a feeling, usually people don't react to it. Yeah, in your book, you describe that you can test your architecture. Let's say architecture in terms of dependencies on teams. Like if you implement a new feature, how many people do you need to bring in one room to find out how, let's say, good or bad your real dependencies are, either your hard dependencies or your soft dependencies. So if I want to implement a new feature and I have to call like a big stuff event, I obviously have a problem. So what's your experience with those tests when you do those tests with your clients?
So my experience is that it's very easy to end up doing local optimizations, right? So organizations always know themselves that we have a lot of coordination meetings, we have a lot of sync meetings, right? And what typically happens is that many organizations tend to stuff additional ceremonies on top of that, right? So we have a problem with sharing information, for example. So let's do additional information sharing meetings. Let's do additional status meetings so that everyone involved is up to date and stuff like that. And in my book, that's basically just a way of kind of covering up the symptoms, not the real root cause, right? Because you really do want to keep coordination and meetings to a minimum. And the only way of doing that is to make sure that each team can operate autonomously, right? So that they can have this fit between an organizational unit and the actual architecture.
Yeah, I mean, I feel the pain already. I've been in, let's say, meetings only with coordinators, and we were like 60 coordinators, where you think, this cannot possibly be true. We also have, like in the supplement material, of course, like screenshots, how you visualize those dependencies between teams. And I have to admit, when I talk about CodeScene, I used to talk only about hotspots, and I totally ignored that feature. So it seems to me that it's even, it's a more important feature. Or, is it more important? I don't know. But to me right now, it feels like it's something you should use in each and every project to really reduce your team dependencies.
Yeah, and I find it fascinating, particularly if we talk about stuff like microservices, right? Where we're very, very heavy upon measuring all kinds of things, right? We're measuring performance, we're measuring scalability and all that stuff. We have an alert system, right? But then we have these other architectural properties that are so important, like loose coupling, independent deployability, autonomous teams. And we are not really measuring that, right? So that's where I think behavioral code analysis can kind of fill that gap. And, it can work like a monitoring system, like an alert system for the architecture. And that's the way I've been using it over the past couple of years. And I have a very good experience with that.
And if, let's say, even alert triggers, what are the typical steps to, let's say, fix the problem?
So what actually surprised me the most, because it was so unexpected for me, that was that a lot of those problematic dependencies between different teams or coordination bottlenecks, very, very often the fix turned out to be technical. It's something we got wrong either in the high-level design or in the architecture, right? We stuffed too many responsibilities into one module, and now multiple teams have a reason to touch that module, right? Or maybe we do have a very modular architecture, but it's the wrong granularity on it. Maybe it's the wrong modeling concepts that we use. And very often it turns out that as software architects, it tends to be very common that we identify technical building blocks and we kind of build our architecture around that. And that's like more or less asking for heavy team coupling.
Yeah, I like that. Little code changes to fix big problems. I mean, yeah, little, but, usually if you have, I'm currently in a project with, let's say, 300 people, and it's incredibly hard to, let's say, without a data visualization on the coupling, to have a meaningful conversation.
Yeah, and I think that even minor improvements at that scale have a big payoff, right? Because imagine just the staff costs of 300 people, right? If you can say 1%, that can be quite some party, right? For that,
exactly. Yeah, I mean, coordination meetings with 50 people every once in a while, why not analyze the code base instead?
You could almost buy a private jet for that money you save, right?
Exactly. Yeah, from my perspective, I could have many more questions, but maybe let's close it here. Thank you, Adam, for the conversation. I can really recommend not only reading your book, but also check out the tool. Yeah, that's it. Thank you.
Thanks a lot for having me. A pleasure.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.